Should totally watch the other parts of this very boring series, link in the description. This is the number line. Over here is 0, here are the numbers greater than 0 and here are the negatives. This makes understanding different numbers easier to understand. So to represent a fraction we find two integers between which it lies. Pretty easy. Divide numerator by denominator. Quotient is the lower number and add 1 and there you go, you found the two numbers. Then just divide the line into divisor parts and the remainderth line is the fraction on a number line. Let's talk about calculus. Sorry if you hate calculus. Remember that I was going to teach limits? So basically there is an algebraic expression. And the variable is said to be approaching a certain number. If you try to replace that variable with that same number, it will give you invalid results. So, this expression evaluates to e, mind that we are not talking about the ones calculators do. This basically means the bigger number you replace this letter with, the closer you get to the value of e, and for the people who don't know this symbol, it basically means infinity or a number that is bigger than all numbers. This operator basically gives the answer which direction it is going, instead of where. Here infinity means nothing. You will never reach infinity, no matter how much you hate Skibidi Toilet. So we always say, going towards infinity. Did the average Joe get it? Thanks bro. So this is the integration operator. It's used to find the area under a graph. So basically this is used to find the area under this graph. To find the area between 2 points. First do the operation, which yields another expression, replace the variables with the points and find difference. That's integration. This is differentiation, not really an operator, but it's used to find rate of change at a specific place on a graph. This is sin and cosine and here are the derivations. To find cos of x, make a triangle with one angle 90 degrees and another as x and divide this by this and sine x is cos of 90 minus x or this. Now that's all for the weird operators I could think of, so the video ends here. Or does it? I completely forgot about some things. Anyway, irrational numbers, let's list a few notable ones, starting with pi, try not to be hungry. It's basically the ratio between the boundary and diameter, which is the longest line in a circle connecting 2 points. A ratio is a comparison of quantities, or basically how much of one thing will be equal to another, if the two quantities are related of course, and it's a word ruined by the internet. Another irrational number is phi, it's represented by this or this if you're nerdier. Go watch Numberphile if you want to know why it's special. It's also known as the golden ratio. That's about all the interesting irrational numbers. I forgot to mention, but the factorials of decimals also yield irrational numbers, or did I? The square root or the second root of 2 is also very interesting because that's the length of this line. The modulus gives the remainder. The floor removes the decimals and the ceiling adds a 1 after removing decimals. So, in algebra there is an expression, it contains constants, variables and operators. A variable is a letter, it has no fixed value, its value depends on where it is. This is a constant, its value is fixed. So a term is a collection of variables and constant related with each other by operations above the first level. An expression is a collection of terms separated by first-level operations. An equation is an expression being said to be equal to another. Now in algebra, doing the same operation with the same number does not violate the equal sign. So to know the value of this, we do these. A way to simplify this is to say that this term switched sides like that bastard Benito in the Second World War and inverted. This inversion depends on the previous operation of whoever switches sides. To simplify an equation, everybody must hate the variable. Now if there are two variables, what do? We make a graph of possible values. The values of y and the values of x. To make a graph like this, we replace a variable with any number and solve for the other variable. This means if y is 2 then x is 15 and plot all points on the graph. It's a straight line if it does not have exponents, so let's see. How do we solve this? Using the quadratic formula, of course. So a numerical coefficient is a constant attached to an expression. For example, this, and this. So a is the numerical coefficient of the squared and b is the coefficient of the normal one and c is the constant, and remember you must get an equation to this phase before solving. An identity we can use is this. Find x and y such that their sum is b, but product is c. There are also some other things I forgot, like the laws of simplification. Closure property of an operation means that for a type of number, like whole, fraction, integer, the operation being done on both of the same type, it will remain as the same type. This is the commutative law. Basically you can jumble the order if they are the same operation, and this is the associative law, I never actually mentioned, but these are called brackets. Anyway, this is the distributive law. I said this in a different manner in my previous video, and heck, commutative law can be a bit mutated, get it? Get it? Nobody gets it? Fine. Actually no, what I said does not match with the commutative law. So in that video I meant that if you do the same operation above the first level multiple times, we multiply the numbers in between. And now we talk about algebraic identities. This is equal to this and this is this, not much of a difference. And to multiply a polynomial or an expression with two or more terms, we use the distributive law, so we get this. And one of my favorites is this one. It makes me happy every time I come across it, and here is another identity. Remember that equation? We call those quadratic equations. So we multiply these and then we find two number when multiplied yield this, but when added yield this. So then we do this and this results in this, because of the distributive law as well. So I forgot to tell, but you might have figured this out already, but like if you multiply 2 and x, we don't show the sign. So that's something. Quick note, when we have minus brackets we multiply -1 and add. And this is another one. I don't get why people say they liked math before they added variables. I mean, how hard is it to understand, man? Now calculus is for later. Bye bye viewers.